Okay, so now we proceed to subtopic 2.2, still subtopic 2.2, which is energy flow through ecosystem, but we look at what is energy transfer. Okay, so this one you have to take note. So what is energy transfer? Okay, producer or plants capture approximately 1% of available light energy from the sun for biomass production by photosynthesis. So you have to remember, okay, actually sun is the source of energy. So from the sun, okay, producer or plant will capture approximately only 1% of the available light energy from sun. So why producer or plants capture 1% of the available light energy? It is for the process of photosynthesis, so that it can produce biomass or biomass production. Okay, and then energy is transferred in one direction. So during energy transfer, conversion of energy occurs and some will be lost as heat. Okay, so only 10% of energy is transferred from one trophic level to another trophic level. So this one I have already explained in the pyramid of energy. So why only 10% of energy transferred from one trophic level to another trophic level? Because mainly energy lost due to respiration and also excretion, and also energy lost as heat to the environment. Okay, so what you have to take note here, producer or plants capture around 1% of available light energy from the sun. So sun is the source of energy. Okay, so why plants capture approximately 1% of the available light energy? It is for biomass production by the process of photosynthesis. Okay, so I will explain based on this trophic level. So let's say, okay, so this is the pyramid of energy. So it will start with producer. So producer is located at the first trophic level. Okay, next is primary consumer at the second trophic level. This one is the secondary consumer located at the third trophic level. The last one is tertiary consumer located at fourth trophic level. Okay, so remember, producer will capture around 1%, okay, of light energy from the sunlight. So let's say if the sunlight have 1 million kilojoule of energy, so 1% from this energy, so producer will get 10,000 kilojoule of energy. Okay, so where is the rest? Okay, where is the rest of the light energy? Where is another 99%? So other 99% of energy will be reflected. So producer only absorb 1% of available light energy from the sun. So why plant or producer absorb the light energy? For biomass production by the process of photosynthesis. Okay, so producer is located at the first trophic level. So what happened to this 10,000 kilojoule of energy? So this 10,000 kilojoule of energy, next this energy will be transferred to the next trophic level, which is second trophic level. But okay, only 10% of this energy will be transferred to the next trophic level. So 10% over 10,000 kilojoule of energy means that primary consumer at the second trophic level only receive 1,000 kilojoule of energy, and then the process will be same to the next trophic level. So for secondary consumer at the third trophic level, so it also will get only 10% from 1,000 kilojoule of energy. So that's why secondary consumer will receive 100 kilojoule of energy. And lastly, for tertiary consumer, it will also receive only 10% of energy from the secondary consumer or from the third trophic level. So tertiary consumer will receive 1 kilojoule of energy. Okay, so this is what we call as energy transfer from one trophic level to another one trophic level. Okay, so okay, this one I already explained. So only 10% of energy is transferred from one trophic level to another one trophic level. Why? Why only 10% transfer from one trophic level to another one trophic level? Because mainly energy lost as heat to the environment, and also energy will lost due to respiration and also excretion. Okay, so one of the favorite question, maybe the question can ask you, why is the number of trophic level less than 5? Okay, why there is not more than 5 trophic level? Okay, because of what? Energy become lesser when transferred from one trophic level to another. So, why energy become lesser? Because energy is lost in respiration, excretion, transpiration, and death. And also, energy is lost through heat to environment. So, what happened to the energy in each of the trophic level? So only small quantity of energy left in the 5th trophic level. So it is insufficient to support next trophic level. Okay, so limiting the number of members in higher trophic level and making ecosystem unstable. So the need for energy increase as trophic level increase. So that's why trophic level is less than 5. Okay, so means that you have to remember or you have to understand the concept of the energy transfer. Okay? Okay, so now let's look at the question. Okay, so this is the question about energy flow through ecosystem. Okay, so the question is, the diagram below shows energy flow in a forest ecosystem. So all values given in parentheses are in kilojoule meter square over year. Okay, so if you look at the diagram, it will start with sun or sunlight. So remember, the sun is the source of energy. So based on the concept of energy transfer, you have to remember, plants or producer will capture approximately 1%, okay, from the available light energy. Okay, so how to calculate? Okay, so 1% over 1.88 10 over power 6. Okay, so you will get, okay, so this is the calculation. So the answer is 18,800. So actually 18,800 we call as GPP. So what is GPP? Okay, so this is the explanation of GPP. So GPP is gross primary productivity. So what is gross primary productivity? Total amount of light energy that is converted to chemical energy in organic material during photosynthesis per unit time. So as a conclusion, once the plants or the producer captured 1%, okay, of light energy from the total available light energy here, so you will get this value. So 80,800 here we call as GPP. Okay, and then you have to remember, okay, from producer, it will transfer only 10% of the energy to the next trophic level. Okay, but the energy is not transferred in form of GPP, but it is transferred in the form of NPP. So what is NPP? Okay, so NPP means net primary productivity. So what is net primary productivity? Okay, between 20 to 50% of the GPP is used by plant in simultaneous respiration and photorespiration, leaving net gain known as net primary productivity or NPP, which is stored in plant. So as a conclusion, it is the energy which is potentially available to next trophic level. So means that, okay, from the energy here, okay, we do not transfer 10% of the energy from GPP, but 10% of energy is transferred from the NPP. So how to calculate NPP? The formula here is NPP equal to GPP minus plant respiration. So let's say plant respiration is 1000. So to calculate NPP, GPP minus plant respiration, so GPP is 18,800 minus 1000. So you will get 17,800. Okay, so remember, in the calculation, you have to write the unit. Okay, so unit is as in the question. Okay, so from this NPP, this value of energy, okay, it will be transferred to the next trophic level in 10%. Okay, so 10% over 17,800. So this is Caterpillar. So Caterpillar is the primary consumer. So it will receive 1,780 kilojoule of energy. So from this total energy, it is transferred 10% to the secondary consumer. So secondary consumer will receive 178 kilojoule of energy. Okay, and then from this total energy here, okay, so it will transfer 10% to the tertiary consumer. So tertiary consumer will receive 17.8 kilojoule of energy. Okay, so remember you have to write the unit here, kilojoule meter square over here. This one also kilojoule meter square over here. Okay, this one also kilojoule meter square over here. Okay, so remember all unit you have to write. Okay, so this is the concept of the energy transfer. Alright.